A nice way to visualize what's going on in a ring is to look at a subring lattice for the principal ideals of a ring. So that gives us a little bit more insight into the structure of a ring. So I'm going to look at Z18 in this video. So what are the principal ideals of Z18? Well, let's see. Let's just go through elements in Z18. So we have 1. So what do we get if we have 1 as a generator right here for this ideal? Well, we get the whole ring back. So that's Z18 right there. What about if we are looking at the principal ideal generated by 2? What does that look like? Well, those are all the multiples of 2. So we have 0, 2, 4, all the way to 16. 18 is 0 again, so we are going all the way up to 16. And then what about 3? Well, that's all the multiples of 3. And so the highest we can go there is 15 in Z18. And then what about the principal ideal generated by 4? Well, you can convince yourself that is the same as the principal ideal generated by 2, so we don't need to write that down separately. So you'd have 0, 4, all the multiples of 4, but since we're going Z mod 18, that will eventually give us 2, for example, and so we get all the multiples of 2. What about the principal ideal generated by 5? Well, 5 is relatively prime to 18, so that doesn't give us anything new. That would be the same as just the 18, so I'm not going to write that down. But what about 6? That would just give us the multiples of 6. Since 6 is a divisor of 18, right there, we're not getting anything other than the multiples of 6. Okay, 7, same deal as with 5. 8, it's going to give us the same as the ideal generated by 2, since it's the power of 2. Not going to give us anything new. And then 9 is going to give us something new, though. So that is just 0 and 9. And then we do also have the principal ideal generated by 0. There is only 0 in here. So those are all our principal ideals. And you can see that there is some order here. Two and 3 generate ideals that are completely, except for 0, they don't have anything in common. But then the other ones are subsets of ones that we already listed before. So in fact, the ideal generated by 6 is a subset of both the principal ideal generated by 2 and the principal ideal generated by 3. And then the principal ideal generated by 9 is a subset of the one generated by 3. And well, the one generated by 0 is a subset of everything. So we could draw a diagram to show this hierarchy. So on the top we have, we're not in red. So we have Z18. And at the bottom, we just have the ideal generated by 0. And then we have 2 and 3, kind of, those are big deals. Those are the big ones. And they are not contained in each other. They don't have anything in common other than 0. So they are not included in in anything other than Z18. They both are subsets of Z18. But then the principal ideal generated by 6, there are different ways to write this, so I'm going to draw it like this. So we have 6, that is a subset of the principal ideal generated by 2 and 3. So I also have that connection right there. And then I have 9, that is only a subset of the principal ideal generated by 3. And, well, 0 is in all of them. So this subring lattice kind of shows us the structure of how all the principal ideals are related to each other and if they are subsets of each other. So I'd encourage you to draw the equivalent subring lattices for Z30 and Z32, and then you can compare them with the solution in the notes.